Is it time to begin?
Yes, please start.
Well, my name is Pavel. I'm working for Code Value. It's a company that specializes in software development and training. And the next hour or so, I want to talk about developing applications for Windows Phone 7. So this is what I want to cover. We'll talk a bit about what's different about Windows Phone in regard to other platforms such as the iPhone and Android-based devices. Then we'll talk about how to develop applications using Visual Studio, get the basics of how to use the tools and emulator that comes with the tools to create applications and test them even without a real device. And then we're going to talk about some more stuff regarding Silverlight and the application lifecycle and other features of Windows Phone as far as time would allow. If you have any questions, I'm going to leave a few minutes at the end of the session to answer questions. You can also type within the link console window, and I'm going to look at that from time to time. Maybe I'm going to be able to answer some of your questions during that period. But if not, I'm going to leave enough time for questions later. So I hope you hear me correctly and the sound is good enough. So what's about Windows Phone? Well, there are many mobile devices on the market today. The leading are Android-based devices and the iPhone, for example. And the main difference is perhaps featured here, people versus icons. Icons are prominent in other platforms, but in Windows Phone, the icons are not that important. The data or the information they convey is much more important. What we can see in the Windows Phone home screen are one of the features of Windows Phone which are live tiles. That means that what we see there are not simply static icons, but information that can change depending on the application. The application has control over how things are going to look on that tile. And we're going to talk a bit about that later. So there are definitely other places to look for comparison and such stuff. I'm not going to cover that. It's not really that important. I want to talk about how to develop applications for Windows Phone. So how to go about doing that. So the first thing we realize Windows Phone is has a platform. It has various aspects. The first thing is the runtime, meaning the actual software that is written and deployed to a device. And Windows Phone 7 currently supports two modes of application development. One is based on the Silverlight model, which is very, very similar to the Silverlight desktop way of creating applications. And the second one is based on XNA, which is a way to create games usually. I'm going to talk about both models, but I'm going to talk more about Silverlight because it's probably more familiar and probably more useful, because maybe even simpler. So there's the runtime, and of course we can't write applications without good tools. So our main tool is going to be Visual Studio, although there are other tools. We can use the regular Visual Studio in a Professional or Ultimate Edition, and we can get the Express Edition, which is free, that allows us to create Windows Phone applications without needing to pay anything in advance. On the other side of the platform, there's stuff that lies in the cloud. That includes various capabilities and options, such as the ability to get notifications. So perhaps my application wants to get notified of things that are interesting. The simplest thing would be something like a weather application. So when the weather changes, I want to get notification to my phone. This is done in Azure Cloud. And this is called specifically push notifications in the context of a Windows Phone. And hopefully I'm going to talk about that a little bit later. And there are other stuff such as the marketplace. So after I'm writing a good application or game, I want to place it in the marketplace so anyone can download that, maybe free of charge, maybe with some advertisement, maybe for money, for real money. So when I'm creating an application, I can submit it to the marketplace. It will go some process of certification, because applications shouldn't crash, for example, and should be according to some guidelines which are well documented. And if those tests pass, my application will be available on the marketplace. This, of course, is a huge opportunity to get your own software to everybody else in the world. So you can take advantage of that. So let's see how do you get these tools. So you go to this URL, createmsdn.com, and there you can download all the tools, get documentation, samples, all other stuff. But basically, if you want to develop just out of something that's completely free, you're going to download the tools, which include the Visual Studio 2010 Express Edition, which is free. You're going to get the Expression Blend 4 for Windows Phone, which is a special version of Expression Blend that is intended just to create a Windows Phone application. Expression Blend is a full-featured tool that is available for in a professional license for WPF and Silverlight development on the desktop, but it's also available for Windows Phone as a free tool. This is more oriented towards designers, so I'm not going to talk about that much. I'm going to focus on Visual Studio instead. There are other tools that come with the SDK, such as the registration tool. This allows me to register an actual Windows Phone device so that I can deploy my application directly onto the device without going through the marketplace. And the deployment tools allows me to deploy whatever zap file I get from somewhere into the phone if I haven't been the one building that application. So if anyone is familiar with the Visual Studio, this is the same tool you all know and hopefully love. So it's very easy to get started. I'm going to show you how to do that in a moment. So let's take a quick demo to see how these things work. So I'm going to open Visual Studio and create a new application. Let's get a brand new Visual Studio. Oh, here it is. So I can find new project, and I can write applications in Visual C# or Visual Basic if you prefer that, or even F# if you are inclined towards functional programming. I'm going to use C# for this demonstration, but it doesn't really matter because Windows Phone supports .NET. That means the actual language is not that important. So I'm navigating to Visual C# here, and then for Silverlight for Windows Phone option here. And this is something that is installed with the SDK, some templates that you can simply use out of the box. So there are various templates here. Some of them just a very simple application, and others are more maybe more complex, but basically they're all pretty much the same, except some of these playback agents and schedule tasks which are complementary and do some other supporting stuff for a normal application. So I'm going to select Windows Phone. Not sure if you're typing anything. I just have one screen today. So I hope you all follow me. If there are any specific questions, please feel free to type in. I'm going to try to answer as much as I can. So I'm going to select here the simplest possible application, Windows application. I can give it some name. Hello, let's call it hello and phone. Give it some directory and click OK. And the first question that I need to answer, I'm targeting. And Windows Phone currently has two runtimes, the original one and the newer one that is known usually as Mango. This is always version 7.1, so I can select 7.1 or the original 7.0. As today, practically all phones already have the 7.1 version. This is one I'm going to select. So I'm going to click OK. What I'm going to get a basic application. We can see how the phone supposedly looks like, and we can do some editing with the Xaml editor, and we can show the toolbox. The toolbox has the controls that Windows Phone supports out of the box, or you can simply type Xaml. If you have any WPF or Silverlight background, then this should be pretty familiar, because this is the same Xaml that you're used to. It supports all the usual stuff. Technically speaking, it is based on Silverlight version 4. So all the features you're used to in Silverlight 4, if you're familiar with Silverlight, exist in Windows Phone. And naturally, because Windows Phone is a different platform, it has some extra ingredients that are required to exercise its capabilities, such as touch support and GPS and the accelerometer and other such stuff, microphone and camera, everything that the phone has naturally has some API, new API to deal with that, which is not in the standard Silverlight 4 SDK. But that's okay. Still, the learning curve is not too steep. Not too steep for anyone that's familiar with Silverlight or WPA. Yes, thank you for that, Ahmed. If you're unfamiliar with XAML, this might look a bit bewildering and maybe a bit confusing, but basically XAML is a way to create user interface. More specifically, XAML is actually about creating objects, but in this context, these objects are mostly related to user interface. So every element is actually an object behind the scenes. So if I select here the grid is actually an object of type grid. And this element means that behind the scenes, a new grid is going to be created. It's going to have two rows. One of them is going to have an automatic height depending on whatever is in that row, and the other row is going to have whatever remains. And you can see the title here. We can see two text block objects here. And this is exactly the thing we see in the designer view. So I can write something like hello phone, to be the name I want to place here. Sorry, this is the name. Didn't get it right, should change the text, not the name. So I'm going to write here hello phone. You can see that the text changes in the preview. Here again, in this text block, change the text to something else, such as the name page or something, and I can see the change right away in the designer. So it's pretty easy to do some stuff. For example, the main content area is here, and this content area can host anything else besides that title that I've just written. So for example, I'm going to create a button here. Simple button, and I'm going to write something like click me here. Here's a button. It's pretty big, and there's a reason for that. It's related to the layout capabilities of Silverlight, and for now I'm not going to worry about that. And let's see what happens. So I want to run this and see how the application behaves at runtime. So how can I do that? So you can see here there is a toolbar that provides me a way to deploy my application either to a real Windows Phone device or to an emulator. So for now I'm going to stick with the emulator, and in the latest service pack, you might call it, to the SDK, there are two emulators. One that emulates a 512 megabytes device with this amount of RAM, and the other one emulates something that is less half than that. That means it's a less powerful device. So we can try either of them to see how our application works. Perhaps if we're going to consume a lot of memory, maybe it's going to be difficult for a low-end device to cater for our application. So in this case, it doesn't really matter. I'm going to select one of them and then just click Go F5. And then my application builds, and for the first time, the emulator comes up. So it's going to take a few seconds for the emulator to come up, and after it does come up, I don't actually have to close it anymore. I can simply minimize it, so it's always available and not have to wait too long for it to appear. So the application is going to be deployed, hopefully. Currently it's loading some symbols, that's why it takes a bit of time to run the application. I can disable that if I want to. And here's our application. We can see the title that I've written, hello phone, and main page. This is our button. I can click the button. I can see something that shows me that I'm actually clicking the button, but naturally nothing happens at this time. And of course the reason is that I haven't connected any event handlers to the button here. So let's change that. I'm not going to close the device, the emulator, I don't have to. I'm just going to go back to Visual Studio and press stop debugging or shift F5 and stop running the application. I'm going to connect to a click event. So we can do that by simply double clicking on the button, just like that, and we're going to get to the code behind. The code behind is the actual class that is created behind the scenes and that supports that Xaml file. So here's my main page class. The Xaml file shows how the UI is going to look like, and I can see that a click property or event handler was added here by the wizard. I could have done that myself. So back to the code, I can see my handler and can do whatever I want in this code. So in this simple example, I'm simply going to use a method that the button was actually clicked. And again, all I need to do now is simply press F5, or I can even press Control F5 and stuff without debugger. This is also possible. And again, I'm going to wait until the application loads up, and this again causes some symbols to get loaded, so eventually it's going to show up, hopefully. Here it is. And then when I click the button, I'm going to get a message box. This is the message box in the Windows Phone style. This is not your typical message box on the desktop, but it's still something that we can use sometimes. So this is a very, very simple application. And again, go back to Visual Studio and start adding some features. I'm going to talk about some more features in a moment. So let's get back to the now. So this is a simple Silverlight application. What about XNA? What is XNA? XNA is a framework for building games. It doesn't really have to be, don't actually have to be games, but games are the typical scenario. They provide API for 2D games and 3D games. And the nice thing about XNA is that it targets automatically or almost automatically with the same API the PC and Xbox 360 and now Windows Phone. That means the API is practically the same. And that means that if I have an existing game that already is running great on my PC or my Xbox, I can turn that into a Windows Phone game pretty easily. I only need to change some stuff that are Windows Phone specific related, such as turn the click of a mouse into some touch gesture, or if I'm using the keyboard on a PC game, I can't. I don't have any keyboard on a Windows Phone. I have to change that to something based on touch or some other buttons that are in the game and so on. But it's, if you're familiar with XNA in the Xbox or PC area, then this will certainly be familiar. So how does a typical game look like? Well, a game is really very different in construction as opposed to Silverlight, which with a regular application. A Silverlight application is based on events. That means nothing happens unless some event is raised, such as the click of the button that I've done previously. It simply means that I'm going to get some event and then respond to that event. Games are typically built in a different way. There's a game loop. That game loop that is running after the application or the game is initialized does some stuff that repeats itself in a rapid succession. For example, the game is going to get user input to see what the user wants to do in the game. Then the game is going to operate its engine, or perhaps a physics engine or other such stuff to calculate what's going to happen depending based on the user input and other stuff that's running in the background, such as the other characters in the game and so on. And then the application is going to draw, the game is going to draw the next frame. And this happens about 60 or perhaps 30 times per second. That means that this happens all the time. It doesn't wait for any event. It works on the basis of polling. Polling means that I'm asking all the time, is there something available? Is there something available? And I'm going to do something about that if it is. If it doesn't, I'm still going to do some stuff that is happening independently of the player's input, perhaps. So here's a typical game loop, how it's actually done in practice. There are actually two methods. One of them is called update. Update is supposed to update all physics or engine-based aspects of the game, while the draw method simply does all the actual drawing of the 2D or 3D content on the screen. And this loop goes on repeatedly, so there's always something on the screen. So how this thing looks like, we can try again building a simple basic game by using the Find New Project wizard here. And this time I'm going to look at the XNA Game Studio 4 here, and I can select a Windows Phone game. So you can see there are other games here that are installed by the XNA framework, but the desktop version of XNA, such as a Windows game and an Xbox 360 game. And as I said, the API is pretty much the same. There are some limitations in the Windows Phone regarding, for example, the number of concurrent playing cells and so on, but basically it is the same API. So I'm going to select a Windows Phone game. I'm going to leave the name as this default and click OK. And again, I'm going to select a target Windows Phone version. And what I'm going to get are two projects, not just one, but two. The reason for this is that the second project actually has the content, or more specifically the assets of the game. This means have various 3D models, sound files, phone files, and other such stuff that are required by the game. So they are built as a separate class library that is referenced within the main game application. So you can see here the game 1 is from the game class, which is an XNA class. And this is actually required. There has to be one such class called that inherits from game. And this is the main class, so it has those methods I mentioned earlier, the update method and the draw method. So you can see the update is doing some logic stuff, which in this case are pretty much nothing at this point. And the draw method does the actual drawing, actually starting with creating a clear display with some color, and then I have to add my actual code here to do some drawing of 2D or 3D content. So if I'm going to run this without adding any kind of code, and again, the emulator is going to show up, and the game is going to run in that emulator. Here will be very boring right now because there's nothing there, just a bluish screen, which will appear shortly. Let's see what's emulator. Loading some symbols, so it won't take 2 seconds to load up the first slide. In the meantime, okay, so we can see not very interesting at the moment, but it is a game. And it doesn't show here, but the update and draw methods are actually called in rapid succession. That means the game is not sitting idly by, like a Silverlight application which simply is waiting for events. Here we're going to update and draw the screen all the time, about 30 frames per second. So showing a complete game is not that easy, but I would like to point out that I can migrate a game that was created for Xbox or Silverlight, Xbox or the PC using XNA to Windows Phone or vice versa pretty easily. There's an option here that says create your project for Windows or for Xbox. Let's try that. We'll create a copy of the project for Windows. Then we're going to get another project which actually shares the sources of the original project, mostly. And if I want to, I can set this to be the startup project. And I can run that if I want to. Just press the Control F5, and this is the game in the PC file. You can see it looks pretty much the same. So even if I have a complete game or a new complete game, I can simply translate that to the other platform with relatively few changes. Most of the changes are going to be around the input. As Windows Phone naturally doesn't support the keyboard or a mouse, it only supports touch and whatever that gives us. So we're going to have to make some changes based on that. And one way to do that and still work on the same source code is simply use the if statement. So if I have a game here that I've written for the PC and I've done that creation for Windows Phone as well, the copy of the project, we can see there's an if Windows Phone here that says if it's a Windows Phone, we're going to do something with the touch panel, for example, and see if a gesture is available. If it is available, we're going to look at the gesture type and do something according to that. But looking not on Windows Phone, the other option is the PC here, so I'm going to look at the keyboard. This is a class that exists only in XNA for PC because Windows Phone actually has no keyboard. And I'm going to read the state here and do something based on that input. So the rest of the code looks pretty much the same. Actually, wherever I have an instruction set, I'm simply going to enclose that in an if and if block here, like in this snippet, and so on. So this is a basic XNA framework. Completion of XNA is definitely beyond this simple demonstration, and I'm not going to talk about that anymore here, but certainly you can check it out later. So we have the emulator. The emulator allows us to check applications or test applications without needing an actual Windows Phone device. And it costs us nothing, simply is provided with the SDK and the tool. All we have to do is simply run the application and the emulator is there. Now naturally, the emulator is an emulator, it's not a simulator, it doesn't have every capability that the actual device has. For example, it doesn't provide the media playback capability, and the only application that is built in is the browser application, and not the other applications that are built in Windows Phone device. But it has, for example, some entries in the address book and the media library, so you can test applications without needing to create actual pictures or actual address book entries. And curiously enough, it supports other interesting features that provide some of the capabilities of the device, such as camera simulation, location simulation, accelerometer simulation, and we have a screen capture tool that we can simply capture the current screen to show perhaps in some presentation. Of course, eventually we'll have to test on the real device. Especially for a game, it is crucial to test on a real device because of performance characteristics that are definitely different between an actual device and an emulator. So let's see a bit about that. So I have a few more demos here. For example, I have a demo that shows where my, let's talk about first. Then to get a feel of the device orientation. and its movements in space. So I have a main page here. All it does is display of the accelerometer. So to use that. And this is my handler. The handler is provided with some arguments here, and the arguments have the x, y, and z offsets in orientation from -1 to +1. So what I'm doing here is simply presenting them in a text block object. If you're curious about this dispatch begin invoke code, this is required because I'm accessing the text block here on a thread. I have to access the text block on the UI thread. However, the event from the accelerometer is provided on a different thread, one of the thread pool threads. So I have to marshal the call to the, and this is what the dispatch begin invoke does here. But doesn't really, not really important at the moment. So I'm going to run this application, and I'm going to look at the emulator. And I can see the orientation is 0, -1, and 0. That actually means that the phone is sitting flat on kind of table or something. So what if I want to change that? I have only a network, not a real device. So there are some extensions here that I can click. And one of them is the accelerometer orientation. So I can drag this red bar, and we can see that the phone is changing its appearance in space, its orientation, and that is reflected in the event and the values I'm actually getting. So this is the way for me to test my application that uses the accelerometer for one thing or another, such as a game or maybe some other interesting aspect. This is the one thing I can check. The other thing I can do is, for example, talk about location. So location means that I want to use my GPS to locate myself somewhere. So naturally, if I'm using an actual device, I'm going to get my real longitude and latitude. And again, for this is pretty simple, pretty straightforward. What I have here is an object called GeoCoordinate Watcher. This is this one. I'm going to create an instance of that, and again, register for an event called position change. And then tell the watcher to start providing events. And this is, again, pretty simple. I'm going to get the code to the event here and simply change some text block with the latitude and longitude I'm provided by the device. So again, if I'm running that, it looks very difficult to test. And again, we have a location here with the tools, and I can search for a location somewhere, or drag myself somewhere, and I can see that the longitude and latitude are actually changing when I'm dragging here and clicking on the actual map. So I have a Bing map here, and I simply click whatever location I want, and the longitude and latitude are changed accordingly. So again, very easy to use, and provides me the ability to test application without an actual device. This is again something that is pretty useful. So these are some of the capabilities of the emulator. So it's pretty fully functional. It doesn't have everything, but it has pretty much everything, or close enough. But again, eventually I'm going to have to use a device. That's something that you can't simply get away with. So I'm building applications, and naturally I'm going to write some code, and that code is going to have bugs. So Visual Studio is used to debug applications, and this is the same experience you have with regular working with Visual Studio. So if you're familiar with Visual Studio, that's going to feel pretty much at home. For example, I'm running some adding machine here, some application called adding machine. It's going to add some numbers, and I want to test that. So I'm running that with the debugger, waiting for the application to come up, again because of some symbol loading. And then I'm going to click some numbers here. For example, let's try to click 54, that will be the first number, and the second number would be, let's say, 1. 54 plus 1. So how much is that? Let's press equals. I'm going to see it's 108. But that's definitely wrong. So I'm probably having some kind of bug in the application. So what I can do, I'm simply going back to Visual Studio and placing some breakpoint here in a handler for my equals button click handler. And then going back to the application, clicking equals again. And notice I'm going to hit that breakpoint. I'm hitting that breakpoint. And from here on, the debugging is pretty much the same as with all experiences with Visual Studio. That means I can step into by pressing step into this toolbar button or F11. I'm going to get to this method, and I pretty much see the bug here. V1 is 54, and V2 is also 54. And the bug here is that I'm simply getting the text from the same text box, so it can't be good. So I know what the problem is. I can stop debugging and fix the code, which is the second number text box, and try it again. This time I'm going to run with some confidence without the debugger and to see if this works correctly. Let's take a 45, for example, and add 1. Sorry, 450 and 1, and the result is 451, and this is the correct result. So the debugging experience is pretty much the same as you used to in Visual Studio Pro if you are a Visual Studio developer. So again, this makes it easy to start. You can simply use the same skills you already know. So you can set breakpoints, you can do some single stepping, you can view variables and modify them. You can do pretty much anything we can do in the regular Visual Studio with regular applications. One thing we need to do if you want to work with the actual device is unlock a device. And this will have to be done using the SDK, and before that we have to register with the App Hub, and that same URL I showed you earlier, createMEAASC.com. And then we're going to be able to unlock the device. And then you can actually deploy application to the device, not via the marketplace, but simply through a connection, a USB connection to the computer. And to actually do that, we need an application that should be running, which is the Windows, the Zoom software client. So we have to get the latest version of the Zoom software client. It has to be version 4.8 this time, and it has to be running. It has to be running, it doesn't have to do anything, but it has to be running. So I'm just running that and minimizing that. I don't actually need that to test my applications. And then simply, I'm going to go to Visual Studio and select the Windows Phone device, my target device, and my device is currently connected to my PC, so I can simply run it. The device has to be unlocked, that means that it has to be outside of the logon screen, and then the application will run the device. So I'm doing that right now, but you probably can't see that, so you have to take my word for it that the application for the editing machine is running on my device. But this is the way to do it. We first have to unlock the device, and then you can simply deploy as usual. And by the way, we can actually do actual debugging while connected to the device. You don't have to do debugging with the emulator, because sometimes some stuff doesn't work correctly only on the device. So I have some errors here. Oh, I have some applications I need to uninstall, never mind that. But we can have a full debugging experience even on the actual hardware device. And this is pretty cool because some features simply cannot be tested on the emulator, or at least not with the same fidelity, so we have to use this device. So basically I showed you how to create a Silverlight application. Now, Silverlight is a full-featured platform that supports a lot of features regarding graphics and animations, and a very rich module for data binding, and this is definitely beyond the scope of this talk. You should get familiar with, even if you're not right now, and that's because the Xaml and the way to build applications using declarative model with data binding is something that's going forward. If you're familiar with Windows 8 that came out in beta about a month ago, Windows 8 is creating or has new Metro style applications which are the same style as the Windows Phone, and they're created in much the same way as Windows Phone application. That means Xaml is key, and data binding and whatever other capabilities we know out of that declarative model is in Windows 8 as well. It's not the same. It's not the same runtime. Windows 8 has different runtime called Windows Runtime, and maybe eventually there will be united with the model for Windows Phone 8 sometime in the future. Maybe, don't know for sure. But the basic concepts of working with XAML, declarative model, data binding, MVVM style applications, if anyone is familiar with that, are the same. So it's really worth your while to learn XAML and Silverlight even if you don't know it right now. And we saw in the new project dialog that we have various templates for applications. They are basically all the same. They're simply using some specific controls such as the panorama control or other controls like the list box that simply gives us some better starting point for some types of applications. I'm not going to show that, but here's the adding machine I showed you earlier. This is how it is actually composed. There's a title, and there's a text box and text blocks and a button and so on. And these are the simplest and pretty much very useful controls out of the box in the Silverlight box. Some of the object model of Silverlight regarding the way controls are built. The framework element class, which is a very basic class that declares stuff common to all elements, whether they are controlled or not. The difference between a control and an element is that a control has a control template, which means we can change its entire appearance very easily without changing anything in its behavior. And again, this is the really deep Silverlight stuff and is something you need to check later on. So I want to find time for perhaps questions. So I'm going to talk about some other stuff that's related to Windows Phone capabilities. I'm going to skip these examples of actual Silverlight. And we saw some examples, so you probably get the idea of how applications are basically built. And one of the things we need to worry about is orientation. So we can hold the phone in one orientation, we can hold it in another orientation, portrait or landscape. An application should do one of two things. Either it should say, I'm always running in some orientation, such as a portrait, or I can say in the properly supported orientation that I can run either in portrait or landscape mode. And that means my application should be adaptable. That means the user interface should be flexible enough so that it looks good enough in the other orientation. We need, of course, to test that. This is usually achieved by selecting a specific layout object, such as the stack panel, for example, that is relatively flexible and can show the right thing in both orientations. Some applications just they do not support the other orientation because it simply doesn't make sense, perhaps. So this is something we need to take into account. It's something we don't usually take into consideration in a regular Windows desktop application because the screen is usually laid out in the same way. So here's an example of a stack panel that is pretty adaptable in this regard, but it really doesn't. You can see the effect here after we allow another orientation. This looks good enough. So we can still add some numbers to get the result. So it's something we have to actually test and make sure that we are running. In the emulator, by the way, there's an option to rotate the device. So currently the application does not allow a landscape orientation, but if it did, the emulator would show the orientation as landscape, or we can actually test this new orientation. So again, the emulator is really pretty good here. It allows us to orient the device however we want. One other nice thing that we can do is, when using a text box, we can change the input scope. you notice that when I ran the application of the adding numbers, I saw the letters in the virtual keyboard. This is really annoying because if I'm going to add numbers, there's no reason to see the actual letters. So you can actually tell Windows Phone to start with a different keyboard. There are a number of keyboards we can select, such as the number keyboard. So we're going to see numbers immediately, and not the letters that would force us to change the numbers mode. So again, this is something that is beyond the classic Silverlight model because we are on Windows Phone, so the text box has an extra property that can be conveyed there. Another thing to note is the application bar. The application bar is something I can show you in the emulator. Let's rotate that again and go to the start. So I'm using Internet Explorer, for example. So this is the application bar. There are menus and there are buttons. This is the button of the application bar. This is a common way to show options in applications. We can show buttons, and for some less common options, we can show the full menu that we can even scroll to if it's very, very big. So this is something that's supposed out of the box in what's called an application bar. You can see here some buttons, and if you play that, maybe it's going to be good enough. So there are buttons that we can select the ellipsis if it exists to show the menu items if there are any. So here's the way to create that in Xaml. So it's simply a matter of using an application bar control, which has a buttons property, and here we're setting the icons for each button and the click handler for that. And then we have the menu items that will be shown only when the ellipsis is clicked or the touch panel is dragged from the bottom. And these are the less commonly used items. Again, we have a click handler for that, and the rest of the stuff is as usual, simply handling the click events. Okay. The other stuff that's interesting, for example, applications are usually composed of more than one page, so we need to have some kind of navigation mechanism. So there's a frame which holds all the pages, and there's actual pages. So we can use some navigation methods to navigate one page. Here's a simple example. Perhaps I have my main page or second page. I want to navigate to another page. In the event handler for some button, I can simply use navigation service property and call the navigate method and provide the relative URL of another Xaml page in my application. And then it will be browsed to that application, and it will be reserved in the back stack. So I'm going to press the back button on the phone and want to get to the previous page. This is pretty simple. You can even do some stuff like go back or stuff like this if you want to, but usually it's not necessary because the back button is always available. We can have it do its own thing. It does that by default, but we can change that if we want. So this is basically the way to create applications with Silverlight. So what if you want some more? Well, there's a project in Codepless called the Silverlight Toolkit for Windows Phone. This is similar to the toolkit for the desktop version of Silverlight, which provides extra controls that are open source and actually created by Microsoft that supplement the built-in controls for Windows Phone. And this is very useful. There are many controls here that you can use, and simply allows you to do more stuff without the need to build your own custom controls or buy them for some third-party vendor. So this is basically the stuff I wanted to cover. There are other stuff such as the application switching and tombstoning and other such capabilities, things we need to worry about. It's related to the application model. But I want to perhaps switch to some questions. So if you have any questions, I'll be happy to try to answer them. You can simply type them in the link text box, and that will be, I think, the most useful. Perhaps I'm going to talk a bit about application switching in the meantime. So one of the things that are evident in Windows Phone is that you can't close an application in some close. You usually don't do that. That's because the Windows OS, the Windows Phone OS, is taking care of that. So if the user moves to another application, your application is going to get into a new state. And that state is activated state. That means the application is still in memory. And if the user presses back or something and gets back to the application is quickly restored to its former state. And everything is going to be pretty quick and easy. However, if too many applications are going to be deactivated, maybe the memory constraints are going to get in trouble, memory consumption may be too high, then the application may even get killed by the Windows OS. So you can get activated in a normal sense, and there are events you can subscribe to get all of that. But the application can actually get killed entirely, and that really means that you have to save state all the time. It's really important to save state all the time. That means that whenever the user leaves the application, when she has to realize that nothing has happened. Even if the application died, or even if the application just was in a dormant state, it doesn't really matter. The user should not feel that anything has changed or anything has lost. And this really is the new model. You don't have some kind of save button or something. You have to do that pretty much all the time. And this is very important for the user experience. So you just need to take that into consideration. This is, by the way, also true for Metro applications for Windows 8. Again, applications there are not easily closed, and you're not supposed to close them. The OS is taking care of that. This is something to look forward to. So that's it. This is the stuff I wanted to cover. If you have any questions, feel free. And if not, then thank you all for listening. I hope you enjoyed that.
Okay, Pavel. Any questions? Seems no. Thank you, Pavel.
Thank you all.
Okay. Thank you. Bye-bye.
Thank you. Bye-bye. תתנדב בדברים האלה. לא מתנדב בדברים האלה יותר.